So everything we're doing is based on this theorem, which says take any integer you want, call it b, as long as it's greater than 1, and then take another positive integer. So what happens is we're able to express express n uniquely as a times k times b to the k plus a times k minus 1 times b to the k minus 1, and so on and so forth down to a1 times b plus a0. Now, notice that we really are just writing everything as powers of b. This b by itself is the same thing as b to the first power, and I don't have a b written here, but I can write that as b to the 0 power. Actually, let me rewrite that so it's a little bit where it's supposed to be. So b to the 0 power. So everything is in powers of b, and they keep getting smaller and smaller. B to the k, k minus 1, down to 1, down to 0. So everything is in terms of b. Now, b in this case is called the base that we're working in. So if we're in numbers the way we usually think of them, we're in base 10 or decimal. If we're in binary, we're in base 2. If we're in octal, we're in base 8. If we're in hexadecimal, we're in base 16. Now, you can do this for any base you want, but decimal, binary, octal, and hexadecimal are the only ones that we're going to be looking at in class this semester. Now, these a's, a to the a sub k minus 1, down to a sub 1, a sub 0, those are what are called your digits, okay? And each of these are non-negative integers that are smaller than b, and the first one has to not be 0. So, for example, if we were to take the number 27,214, this can be written as 2 times 10 because it's a decimal number. And so we need to see what power we're going to put on 10. Well, here is the 0th power, the ones place. Here's 10 to the first place, the tens. 10 squared, the 100s. 10 cubed, the 1000s. And 10 to the fourth, the 10,000s. So this is going to be a 2 times 10 to the fourth power plus a 7 times 10 to the third power plus 2 times 10 to the second power plus 1 times 10 to the first power plus 4 times 10 to the 0 power. Now, that looks really bad, so let me fix those last few ones that I've written down over there. So let's see, 2 times 10 to the fourth, plus 7 times 10 to the third, plus 2 times 10 squared, plus 1 times 10 to the first, plus 4 times 10 to the 0. Now, you don't have to write 10 to the first power. You could just write 10. You don't have to write 10 to the 0 power. You can just leave it alone. But I recommend that you do, because that'll make it a little bit easier to see what your highest power should be when you're doing this, especially in bases other than base 10. So again, this is decimal or base 10. And what are the digits when you're in base 10? So the digits when you're in base 10, it's going to be all the numbers that are less than b, which is 10 in this case. So all of the non-negative integers that are less than b. So the digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So in different bases, you'll have different digits. And we'll see how that works right now.